Hello everyone, welcome to the channel StatisticaHub. So we were discussing the MSQ part of the JAM 2023 paper. So continuing with that part, today we'll be discussing few more problems from that. Okay, so let's see it. So yeah, firstly you can see on the screen there is a question number 31. So let's see it. It is saying that let M be a 3 cross 3 real matrix. Okay. If P is equals to M plus M transpose and Q is equal to M minus M transpose, then which of the following statements are always true? Okay. So it's a MSQ question, so maybe one of the options are correct. Okay. So let's see what is the given information. That is M is a 3 cross 3 real matrix where P is equal to M plus M transpose and Q is equals to M minus M transpose. Now if you remember this point that we have studied that any matrix can be written in the form of symmetric and the skew symmetric matrix. Like let's say this is the matrix M. This can be written as M plus M transpose by 2 plus M minus M transpose by 2. Okay, which is actually our P plus Q by 2. So from this we can say that P is my symmetric matrix, okay, and Q is my skew symmetric matrix. Okay, so P would follow P transpose is equals to P and Q is Q transpose is equals to minus Q. Okay, so that is the information that they were trying to tell us. Okay, now let's see the option number A. The option number A is saying that the determinant of P square Q cube is equal to 0. Okay, so we need to check this. Now we know that the determinant of skew symmetric matrix of odd order is always 0. Okay, so Q is my skew symmetric matrix. So the determinant of the Q would be 0 because we know the determinant of skew symmetric matrix of odd order is always 0. Okay, so this is going to be 0. Now what do we have? Now see, firstly this thing can be written as determinant of P square into determinant of Q cube. Okay, so we know that the determinant of Q is going to be 0 because it's an odd order matrix. Okay, and we need to check for the determinant of Q cube, that what would be the determinant of Q cube. So for that what you can do, you can just check on this Q cube, so whether this is a skew symmetric matrix. So if it is a skew symmetric matrix, then we will say that its determinant is also going to be 0 because it will also going to be a 3 cross 3 matrix, that is odd order matrix. Okay, so what we need to check whether this Q cube is skew symmetric or not. Okay, so yeah, we know that Q transpose is equals to minus Q. Now we are checking for Q cube. Okay, this Q cube is actually, we are writing Q cube's transpose is equal to, what is this equal to? This would be equal to minus Q's cube. Okay, so basically it is satisfying the property of the skew symmetric, that is Q transpose is equals to minus Q, or you can say Q cube's transpose is equals to minus Q cube. Okay, so from this we can say that Q cube is actually skew symmetric matrix. So as it is a skew symmetric matrix, so the determinant of Q cube is going to be 0 because Q cube is of odd order. Okay, so this term would go to 0 and the final thing, that is the determinant of the whole thing, is going to be 0. So the first option is correct, that is determinant of P square Q cube is equal to 0. Okay, you can, if you are confused about the determinant part, you can just check it. If you know if you have studied the skew symmetric matrix, then remember this thing where we find out the determinant like this. The determinant of Q transpose is equals to minus Q, that is minus 1 to the power n, and determinant of Q, where it depends on the order, that what is the order of the matrix. If n is of odd order, then the sorry, I have written this Yeah, you can use it anyway. Okay, so it depends on the order. So if it is even and whether it is odd. So here we have odd order. So in the odd order, the statement is always true that the skew symmetric matrix would always be 0. Okay, sorry, determinant of skew symmetric matrix is always 0. So yeah, that's the option number A. Now let's see the option number 2. It is saying, what is it saying? That the trace of q plus q square is equal to 0. Okay, now see, in the skew symmetric matrix, every diagonal element of skew symmetrics is 0. Okay, so the diagonal element corresponding to the q are going to be 0, but we need to check what about this q square. Okay, we need to check for q square. So firstly we will check whether this q square is skew symmetric or it is symmetric. So when I am doing q transpose square, that is equals to minus q square, that is coming out to be q square. So it is saying that the q square is not skew symmetric. Okay, q square is not skew symmetric, so we are not sure about whether the diagonal elements are going to be 0 or not, because the diagonal element in this case are not necessarily 0. Okay, so what you can do in this question, you can just take some random matrix. That is the best method to do, that you can just take the matrix, let's say q, which is my skew symmetric matrix. I'm just choosing any matrix that is skew symmetrics. Okay, like this. Okay, let's just choose any matrix. So this is the matrix that we have. Now let's take a square of this matrix. So if I do the square corresponding to it, let's see what are we getting. We'll be getting minus, I'm just calculating the diagonal elements because it is just saying that the trace is basically the sum of the diagonal elements. Okay, so I'm going to only find out the diagonal elements corresponding to it. That is going to be this is minus 2 and this is going to be 0 1 0 and yeah, minus 1. So as you can see, the trace of this matrix, the trace of this matrix is not equal to 0. So and the matrix and the trace of this q is equal to 0. So this statement is not true. Okay, so yeah, you can take some dummy matrix corresponding to the q, that is the skew symmetric matrix. The property has to be satisfied basically. You can take the square of it and just find out the trace corresponding to it. Okay, we can do this also. Now let's see the option number C. What is it saying? The option number C is that x transpose q square x is equal to 0. Okay, it is saying option number C is x transpose q square x is equal to 0 for all x belongs to R cube. Okay, now what is this? This is actually the quadratic form. Okay, now let's see, try to focus on this q square part. Okay, now we know that the eigenvalue of skew symmetric matrix, either these are going to be purely imaginary or either these are going to be 0. Okay, either it can be purely imaginary or a 0 number. These are the possible cases. So q is my skew symmetric matrix. Okay, so what are the corresponding eigenvalues it can have? It can have 0 or either it can have, let's say, plus minus ia. That's a random eigenvalue we are considering. Then what about q square? Q square would be the square of the eigenvalues. We have studied this portion in the characteristic equation part, in the eigenvalue part. Then it would be minus a square and plus a square. Okay, now focus on this portion. This is x transpose q square x. Okay, now corresponding to the eigenvalue, for eigenvalue, what would be the eigenvalue? Eigenvalue corresponding to q square, we are taking that as lambda. Okay, let's just denote them as lambda. So that would be x transpose lambda x. Okay, now this thing can be written as lambda x transpose x. So q square's eigenvalue are non-zero. Okay, these are non-zero eigenvalue. So this value can't be equal to 0. So because it is asking for all x, it may be true for some of the x's, but it is not true for all of the x's. Okay, that's why we are saying that this option would be incorrect, because eigenvalue is non-zero. We are having eigenvalue that is non-zero, and this quantity that is also going to be non-zero. So the full quantity, this is not going to be 0. Okay, if you don't know that how to process with this kind of process that I have just told you, it is just a very short method, so it will save you from the calculation if you already know this concept of the eigenvalue and eigenvector, that thing. Okay, if you don't want to do this process, what you can do, again take some random matrix. Okay, so I'm just considering that my matrix M. Okay, my matrix M is, I will fully calculate this portion and check whether this is coming out to be 0 or not. Okay, so this is some another method, that is M. Let's take M, that is some matrix 0 0 1 0 0 0 0 0 0. Okay, I'm just taking the easiest matrix so the calculation would be easier. Now what would be the M transpose corresponding to it? M transpose, that is 0 0 0 0 0 0 0 0 1. Okay, now we are going to calculate our P. What is our P? P is M plus M transpose. Okay, so that is the addition of these two matrices, and Q was M minus M transpose, so that is going to be 0 0 1 0 0 0 0 0 minus 1. Okay, so we got our P and we got our Q. Now what is it saying? That is x transpose q square x. We don't need to calculate P, but yeah, we have calculated it, so it's okay. What will be q square from it? So we'll just multiply, right, like take the two matrices corresponding to it, that is q into q. Okay, let's just multiply it. That is going to be 0 0 0 0 0 0, and the last portion, that is minus 1 0 and 1. Okay, so this is my q square. Okay, now let's say x transpose q square x is equal to 0. It is saying that it is equals to 0, but we need to check it. So that would be, let's take the vector x y z. The matrix is 0 0 0 0 0 0 minus 1 0 1. Okay, and this is x y z. We are going to check it. So the corresponding matrix that is here, this will be minus z 0, that would be coming out to be a c, x y z. So we are getting minus zx plus z square, which is not equals to 0. Okay, so by solving all these portions, we got that the matrix is not equals to 0. So if you are like, you can just choose the matrix that is like dummy matrix, that is easier to solve. Choose the elements like that. Okay, and just solve q transpose q square x, x transpose q square x, and that will give you the result. Or either you can apply this process also, which is corresponding to the eigenvalues. Okay, that will be having non-zero eigenvalues, so it will not be true for all the things. Okay, so the third option that we are getting, that is incorrect. Okay, now the fourth option. What is the fourth option? That is x transpose px is equal to twice of x transpose mx. Okay, let me just write it here. That is x transpose px is equal to twice of x transpose mx. Okay, for all x belong to Rq. We have to check this. Now in this, let's just take M is equals to identity matrix. Okay, then what would be P? P is M plus M transpose. So if M is identity, then M transpose is also identity, and then P would be twice of identity. Okay, and what would be Q? Q is my M minus M transpose. So the Q would be 0, because identity minus identity, that would be 0. So this is my P and this is my Q. What is the matrix? The matrix is, sorry, the equation is x transpose, what is P? Twice of I. Okay, x. What is this going to be? This is going to be twice of x transpose x. Okay, now let's check this one. That is twice of x transpose mx, and what is M? M is identity, so twice of x transpose ix, that is twice of x transpose x. So yeah, left hand side is equal to right hand side. So this is satisfying. Okay, because we are getting twice of x transpose x here also and twice of x transpose x here also. Okay, so you can just try this, or what you can do, you can again just take the random matrix that like I have done for the option number C. Okay, you can do with that portion also, like you will find out P, you will find out M, and you will check for x, like just solve it and whether they are equal or not. Okay, so we have, for now we have taken the identity matrix and it is successfully satisfying it. Okay, so the option number D is correct. Okay, so in this question, what are they actually asking? This question is mostly about the properties. Okay, if you know the properties, then you know how to solve it. If you don't know, then maybe it would take some time. Okay, before the calculation, because you are going to consider some matrix, that is P symmetric, Q symmetric matrix. Then you are going to find out that, let's say, P square, Q cube, like that. If you are going with the like process of finding out the matrix calculation with the corresponding to matrix, then it would be like maybe it would take some time, but also then you can solve this question. Okay, so it's more of the part about the properties of the corresponding to symmetric and the skew symmetric portion, and some of the quadratic also. Okay, so yeah, that's about question number 31. And now let's see question number 32. Okay, so what is in it? It is saying that let x1, x2, x3, x1, x2, x3 be IID random variables, each having the normal 0, 1. Then which of the following statements are true? Yeah, I like these questions. Like these can be solved in very less time. Okay, if you know the properties. So it is saying xi, which is normal with 0, 1. Okay, and what are these? These are IID, and I is 1, 2, 3. Okay, so let's talk about this A part. What are the variables in the A part? That is x1 minus x2. So what is x1 minus x2? x1 minus x2 would follow normal 0, 2, right? And x1 plus x2, that would also follow normal 0, 2. Okay, like if you know the property that if x1 is following normal mu1 sigma 1 square, and x2 is following normal mu2 sigma 2 square, then x1 plus x2 would follow normal with mu1 plus mu2 and sigma 1 square plus sigma 2 square. Okay, and for x1 minus x2, it would be normal mu1 minus mu2 and sigma 1 square plus sigma 2 square, like this. That's the property we are using here. Okay, now let's just see. It is saying that it would form T, so try to form the we are trying to form the T1. Okay, so yeah, let's just see the denominator part, that is x1 plus x2's whole square plus 2x twice of x cube, x3's whole square. Okay, so we have x1 plus x2 divided by root 2, that is going to be normal 0, 1, that is x minus mu by sigma, the z part. Okay, and what is this? This, if I'll do the square of it, okay, this is going to be chi square 1. Okay, this is my chi square 1. Now see, it is saying x1 plus x2's whole square upon 2 plus, if I add x3 square in it, where x3 is following normal 0, 1. Okay, so again x3 square would follow chi square 1. Okay, so this is following chi square 1, this is following chi square 1, so this whole term would follow chi square 2. Okay, so what are we saying? Let's see it. They are trying to form T. So for T, what is the condition? That the denominator is actually the normal part, and the numerator is the normal part, and the divided by root of chi square by n. Okay, so what is normal? Normal 0, 1. So x1 minus x2 upon root 2, right? That is my normal 0, 1, divided by, this thing is only normal 0, 1, root of chi square by 1. Okay, what is chi square? Chi square is x1 plus x2's whole square divided by 2 plus x3's whole square divided by 2, this whole portion divided by 2. So and this time this is following chi square 2, and this whole function would follow t with 1 degree of freedom. Okay, now let's see what is in it. It is whether this function is exactly the same function that we are writing or not. Okay, so if I'll simplify it, then it would be x1 minus x2. This 2 is actually 2 to the 4, so 2 would cancel out with the 2 and this would go into the numerator. So that would be root 2 and x1 plus x2's whole square plus x3's whole square root. Okay, and this is following t of 1. So the first statement, that is 8th part, that is true. It is following t1. Now let's check for the second part. What is the second part? The second part is saying, I'll just remove this. Okay, now we have to see whether this is forming f of 1 comma 2 or not. Okay, so for f of 1 comma 2, okay, now we know that what is f of 1 comma 2, how does it form, where a chi square divided by their degree of freedom divided by, like it is something like this, chi square divided by its degree of freedom v1, and again chi square function divided by degree of freedom v2, then it would follow f of v1 comma v2. Okay, we know this property, so we will be using that here. Okay, so the upper function, what is the function that we are having? That is x1 plus x2's whole square. Okay, now we know that x1 plus x2's whole square divided by 2 is following chi square 1. Okay, and what about the denominator part? That is x1 minus x2's whole square. Okay, so we know that the x1 minus x2's whole square divided by 2, this would also follow chi square 1 plus x3 square, that would follow chi square 2. Okay, now we are going to form f corresponding to it, because these are the functions. So let's just see. So x1 plus x2's whole square divided by 2. Okay, this is the function divided by its degree of freedom. Okay, and x1 minus x2's whole square, I'll just simplify it here only, 2x3 square divided by 2 divided by its degree of freedom 2. Okay, so what is the final function? Now this function would follow f of 1 comma 2. Now let me just check whether these functions are same or not. Okay, so this 2 and 2 would cancel out, and what are we having? This is actually twice of x1 plus x2's whole square upon x1 minus x2's whole square plus twice of x3 square. Okay, so yeah, so this is square basically, sorry. Okay, so we are not having 2 here constant that is required to form this as f of 1 comma 2. So this is not exactly the same function that we are forming. So yeah, that is incorrect. Okay, now the option number C. Okay, now if we are talking about the option number C, that is expectation of x1 upon x2 square plus x3 square. Now if you look this very closely, we know that x1, x2, x3 are in IID random variables. Okay, so we can break this expectation as expectation of x1 and expectation of 1 upon x2 square plus x3 square. Okay, and we know that x1 is following normal 0 comma 1, that is expectation of x1 is 0. So as the expectation of x1 is 0, so the whole term would go to 0. So this option is also correct. Okay, now we have to check for the option number D. Okay, that is saying that the probability x1, let me just make some space here. Okay, sorry, it is saying that probability x1 less than x2 plus x3 is equal to 1 by 3. Now this probability can be written as x1 minus x2 minus x3 is less than 0. Now we can compute it. Okay, let's try to compute it. Firstly, we need to check what does x1 minus x2 minus x3 follow. Okay, so again by using these property, x1 minus x2 minus x3 would follow normal 0 comma 3. Okay, so let's say this is some s. Okay, this function is s. So we are going to calculate probability s is less than 0. Okay, now let's try to form this as z. So z, where 0 less than 0 minus 0 divided by root of 3. Okay, so that is probability z is less than 0. Now probability of z is less than 0 can't be equal to 1 by 3 because that is 1 by 2. Okay, so this option is also incorrect because this probability is not equal to this portion. Got it? Okay, so yeah, that's the wrap of this question, question number 32. So our option A and C are correct options. Okay, in this question you should know the properties of the distributions, that how one is interlinked with the another. Okay, yeah, so this lecture is about question number 32 and 31. I hope you understood. Okay, so yeah, have a nice day and let's meet in another lecture. Thank you.